The Fact Novelty framework aims to identify new information directly within videos. Its goal is to automatically assess whether new content contains novel information compared to previously collected material. As exemplified on the right, the task is to determine whether the lower video presents fact-level information not found in the upper one. To begin with, we automatically generate captions in English natural language using a video-to-text V2T machine learning model. Next, we use a specialized prompt with the large language model LLM to extract a list of structured facts. Given two videos, we process the first to obtain known information and the second to obtain test information, both in unstructured and structured textual format. A follow-up LLM prompt then compares the two and identifies any novel content in the test video, producing a final list of novel facts. Importantly, all models, both vision language and large language models, are hosted locally. We developed a video-to-text server that can segment input videos into shorter clips using an internally developed shot boundary detector. These truncated clips are then captioned. For the actual video-to-text part, we employ a locally run vision language model, intern LM X Composer 2.5, with a simple prompt. Importantly, the audio track is not used, allowing us to clearly isolate information derived solely from the visual content. The exemplified descriptions demonstrate the model's strong video understanding capabilities, including recognition of on-screen text. However, it occasionally adds interpretive or sense-making elements to complete sentences. To demonstrate fact novelty detection, from the two previous source videos we isolate three segments, A, B, and C. We then merge segments A and B and segments B and C together. This resulting overlap setting simulates a complementary scene. Finally, we generate a textual description for each merged segment. Moving on to structured fact extraction, we utilize a locally run instance of Meta's Llama 3.1 with fixed settings and no sampling. The model is prompted to perform atomic fact extraction. We aim to restrict to sentence predicate object sentences with included context, modalities, and pronoun resolution. Finally, outputting a machine-readable list of facts for downstream processing. The extracted facts are listed above the raw JSON response of the LLM server. For the actual novelty detection, structured facts are matched against unstructured captions. In this example, the caption of the first segment AB is matched against the structured facts from the second overlapping segment BC. Each comparison is classified as either new or not new, using a specialized prompt that aligns core information while preserving negations, modalities, and including reasoning for each decision. In ambiguous cases, the default classification is new. Since chained or dependent LLM calls sometimes produce syntactically incorrect dictionary outputs, we apply an additional LLM call to correct formatting when traditional methods fail. Naturally, this matching process is also performed in the reverse direction. As intended, information shown in the overlapping segment B is correctly classified as not new. For example, the significant loss of coral over the past 27 years. In this example, 6 out of 11 new facts are identified as new. In the opposite direction, we detect 9 out of 14 facts as new. This demonstrates the framework's ability to automatically detect novelty in incoming video content, in this specific case using video and more generally using any textual input.